Well, Scott, if you are ready, I think we can go ahead.
All right, I am ready. Welcome, everybody. Thanks for joining today. We're excited to have you. Today's topic is one that we feel we needed to give because we see this a lot in our I won't say day-to-day business, but we frequently get questions about this. So we thought we'd do a webinar on really kind of SQL Server best practices and ideally, how to not jack up your log chain, right? How do I, what are best, a backup and restore best practices? Why are our restores or not, breaking, things like that. So we thought we'd just kind of do a 100, 200 level SQL Server backup best practices, and really how that pertains to the log chain and how not to break that. And so we're going to spend the next, 45 minutes to an hour talking about that, because this has actually come up quite frequently in our business. So a quick introduction about myself. My name is Scott Klein. I'm a senior consultant with SQL Solutions Group. I've been doing SQL Server for a really long time, 30 plus years. I got started right when SQL Server 6.0 came out. I hate to admit it, but I was actually doing Access before that, and 4.2 to 6 had just come out, and I started playing with, started getting started with that. So I've been doing SQL Server for a long time. Prior to joining a SQL Solutions Group recently, I was I worked for Microsoft as a data platform evangelist for a few years, and then from there went into kind of the worldwide learning and developing some of the data analyst certification and content and things like that. So I've been doing data for a really long time. I love it, and that's kind of what I live and breathe. So a little bit about SQL Solutions Group, and then we'll dive right into the agenda. So you can think of us as we've been doing SQL Server for a long time. We've been in business 10 years. It was started by Randy Knight, who's a Microsoft certified master. We're a fully certified SQL Server consultancy. So we have a number of clients around the United States in many different industries. So we do training, remote DBA, SQL coaching. We make sure that your SQL Server environment is up to par, doing what it's supposed to be, with high availability disaster recovery, making sure that it's healthy, things like that. So, we work really hard with you and your to make sure that your SQL Server is doing what it's supposed to be doing and doing it the right way. So that's what we do, and it's been a lot of fun working with SQL Solutions Group. Okay, with that, let's talk about what we're going to actually talk about today. And here's the agenda. Some of this might be kind of, I know that, but we're going to talk about it because we see some confusion around kind of these things from a backup perspective. What's high availability and disaster recovery? What's RTO and RPO? What are those, and how do they have to do with backups and restores and your log chain and things like that? We're then going to talk about backup types, and this you're probably going, I know that, but we do need to cover that from a SLA perspective, right? And then we're actually going to talk about the log chain, and really the purpose of this webinar is the log chain. How do you do backups, and what happens to jack up your log chain, and when your log chain gets jacked up, that messes up your RTO and your RPO and your disaster recovery plan and things like that. So we need to talk about that, because this is really what we see in our day-to-day business, is people jacking up their log chain and they don't know why it's jacked up and messed up. So we got to figure, so today's webinar is really about, how do we understand backups and how not to break your backup strategy, and how to keep your SLA around backups and your backup strategy. So before I jump into the presentation, the way I'm going to structure this is to demo this. We're gonna end with a demo, but I need to get the demo started here. So what I have here is a very simple database called SampleDB. It's got one table in it called friends, right? And what I'm going to do is I've got to I needed to polish up my .NET skills. So I've got a very simple .NET program that goes through and inserts a simple record into that table every 15 seconds, right? So it just endlessly loops to insert a record. So I'm going to kick that off. And let me bring this window over. Where's it at? There we go. So this connected to the database. Now I'm inserting records. And then what I'm going to do is, after this inserts a few records, what I'm going to do is I'm going to run this in SQL Server Management Studio. And what this statement does, it first takes a full backup of the SampleDB database. It waits 5 minutes and then starts taking transaction log backups every minute. Okay, so hopefully that makes sense. We're inserting some records, and then while it's inserting records, the first thing we're going to do is take a full backup and then take some logs. So we've got about 4 records in there. Let's just kick this off. All right, so execute that. So we've taken a full. Now that's going to wait 5 minutes. And now after 5 minutes, it's going to loop every minute and take a transaction log backup. So we're going to come back to this in just a few minutes. So let's go back to the presentation. All right, so that's our agenda. Let's talk about high availability and disaster recovery. The reason we're going to talk about this is there's a little bit of confusion. These are not, while they are related, they are not the same. They're very much related. So I don't want that to be mistaken. They're very much related, but they are not the same. HA essentially means don't have an outage, help me not to have an outage, but disaster recovery says if I do have one, how do I recover from that outage? So high availability essentially says availability is a measure of the ability of clients to connect to and use a resource. So really high availability says, are my resources up and available so my clients can connect to that? We want to say essentially a high availability resource is almost always operational, accessible to clients. We would like that to be 100%. That's not, typically not always true, but essentially it is. We want our resources, whether it's data, resources, machines, to be always operational and accessible to clients. And we want the ability to recover from any type of failure that affects that service or data. So if something happens, how do we, if I'm got a SQL Server always availability group and one of the nodes goes out, it fails over to the other one, so our data is still available and our services are up and running. That's high availability. How do we make sure that our services and our data is always available? If a resource is not available, clients can't use it. So typically a high available system adheres to some level of agreed upon performance and uptime. This is your SLA, your service level agreement. What is our agreed upon level of performance and uptime? And this is high availability. This pertains and is very related to our disaster recovery. So high availability says, I want to make sure in the chance of some sort of disaster, my data is still available, right? If there is some sort of disaster and I need to recover, how do I recover from that? And that is disaster recovery. This is a process or a series of processes that is used to recover from some type of failure. And that failure can be either a single item or an entire physical location, right? So, someone unplugs the machine or turns it off, do we fail over? Is that one machine, or is it like the data center? So a good example of that was, I want to say less than, almost 10 years ago, not quite 10 years ago, we were living in Florida, and it was hurricane season. Typically in hurricane season, Florida gets it, Texas gets it, you know, kind of Louisiana, you know, that area of the United States gets it, Georgia, South Carolina. These guys get hammered all the time by hurricanes. Occasionally, and at this time, what happened was this hurricane through and is headed right toward Florida and Georgia. They were they were bracing for this huge impact. It was a pretty serious hurricane. I think it was a Category 4, maybe even a 5. It was, you know, serious. And the moment it was going to hit the south, it stopped and headed north, and it kept its momentum, and it hit the New England area and wiped out, you know, a lot of businesses weren't prepared to handle a hurricane. And so, you know, they had a lot of their data centers were out, and they spent some serious time doing disaster recovery, getting back up and running, because they didn't have a lot of companies didn't have plans for that type of disaster recovery. Right, so lessons learned. It was kind of weird, but I clearly remember that. So, you know, in this case, it was an entire physical location that went down for many companies. It wasn't just a single item. So, you know, high availability says we've got to make sure that our data and our resources are always available or available as often as possible. And disaster recovery says, how do I recover from a failure? What are the steps and processes to recover from sort of disaster, right? So again, they're different, but they're very much related. And this has to do with what we're talking about today, backups. If we have to recover our data, what's the process, right? And we'll talk about that and how logs and log chains affect that very much. So hopefully that makes sense. All right, from there, let's talk about RTO and RPO, and this is really your SLA. This is recovery time objective and recovery point objective, and we'll talk about each of these. Let's start with recovery time objective. Recovery time objective really essentially says how much downtime is acceptable when a disaster happens or for planned outages, right? If you know something happens, whether it's a single resource or an entire data center, how much time is acceptable to be down before we can be back up? This is typically measured in minutes, hours, days, or weeks. We don't see a lot of days or weeks, but you know, a lot of times for mission critical businesses, this and mission critical applications, this is minutes or hours, and hours at most, right? I see this a lot in the terms that we call nines, right? 3 nines, 4 nines, 5 nines. You can look this up. It's on the interweb out there. You know, 3 nines, so 99.9% equates to about, you know, almost 9 hours per year of downtime. You get to 4 nines, 99.99%. That's about 52 to 53 minutes of downtime a year. And you get to 5 nines, right? That's 99.999% of downtime. That's about 5 minutes per year. That's pretty, you know, it's pretty significant. Five minutes per year, you're not down long. What I mean by significant. So RTO is based on, you know, is measured in terms of nines. So what does this mean for you? That to decide what RTO is best for your company, you need to take in consideration your data needs, right? Not all companies run on a 365/24 schedule. Some companies only measure downtime between Monday through Friday, 8 a.m. to 6 p.m., for example, or you know, they didn't include the weekend. So what your RTO, your defined RTO, your SLA for RTO, it will drastically change based on the translation of the nines for you, right? What is the RTO for you? Can you do, you know, is it 365 by 2024 365? Is it, you know, just 8 to 6 Monday through Friday? You know, are weekends important to you? This is what you decide, but it's, you know, what is the recovery time to recover for a disaster? Okay, so that's something you have to decide what's best for your company for that SLA, right? So with that, let's then talk about recovery point objective. So RTO is time, how much time it takes to recover from a disaster. Recovery point says, what's the level of acceptable data loss if that disaster happens? So, we may take, a half hour to recover or whatever long to recover, but how much data loss is acceptable to recover from that disaster? And this is why we're talking about this today, because this is completely 100% dependent on your backups and how valid your backups are, right? So for an example, an RPO of 15 minutes means that the data must be recoverable to within 15 minutes of that disaster, which means you're okay losing 15 minutes of data. Is that okay with you, right? Is that okay for your business, right? You may have an RPO of 0. You may have, which I don't think is realistic, but, is it 15 minutes? Is it an hour? What is the acceptable level of data loss in the event of a disaster? And again, this is meant, now again, these are very much related, because you can't have RPO and RTO without RTO and vice versa. These are very much related. But this is important when you're defining your backup strategy and your SLA for RTO and RPO, right? What does this mean? And again, I cannot stress enough, this is completely dependent on the validity of your backups. And a good backup strategy says, yep, I'm taking backups. And we're going to talk about type of backups in a second. We're taking backups, but have you tested those backups? Have you tried to restore those to make sure that they're valid and kind of run through a disaster recovery scenario, right? That's critical. We're not going to get into that, but again, a good backup strategy says, yeah, about once a month, I'm going to go and try to restore, pretend that there's a disaster recovery and restore. I'm going to take the last full differential and log and back those and restore those to make sure that they're all valid. So just a FYI to keep in mind, okay? Okay, ideally, companies will want 0 data loss or work loss, but I think that's personally, now people may disagree. Personally, I think that's difficult to achieve. You can get close, but you want to get as close to that as possible. So it all depends on your backup strategy, right? So, okay. Let's talk about backup types. Now this, you may go, yep, I know these, but I think we need to dive into these a little bit just to build a foundation about how it pertains to the log and log chains and your backup strategy. So there's 3 backup types, right? There's obviously we know that there's the full, and a full is basically we're going to take, it backs up the entire database and including the transaction log. We're just say take a full backup, give me everything, all the transactions, the full database and the transaction log. And for the most part, unless we change it, all the contents of that backup are contained in a single backup file, typically a .back, right, is the default. This is probably the most common that we're familiar with, but it's a full backup, right? It includes the entire database, including the transaction log. Hopefully we're familiar with a differential or a diff, right? A diff contains only the data that has changed since the last full backup, right? So if we take a full and then we wait an hour and take a differential, then that differential will contain all the data and transactions since the data since that last full backup. Okay, and we'll kind of get into an example here in a little bit. Hopefully we're very familiar with log backups, right? This log backups contain all the transactions since the last full or differential backup. What we need to understand, and hopefully this is everybody knows this, but you can only back up the log if your database recovery model is set to full or bulk logged. And this is one of the ways that you can jack up your log chain. We'll actually talk about that in a little bit, is changing your database recovery model and how that affects your log chain. Right, so there's so you got the full, the differential, and the log. We'll talk about kind of an example here in a second, but to be clear, I want to back up to the differentials a little bit. A differential, like it says here, contains only the data that's changed since the last full backup. If you were to take a full backup, then a differential an hour later, followed by another differential an hour after that, so you have a differential, and then another differential. Both differential backups will contain the changes since the last full backup. That second full backup, that second differential backup will contain the contents. It will include the contents of the first differential backup. Hopefully that makes sense. I take a first differential an hour later. That contains all the changes since the last full. But if I take a second differential, that still contains all the data changes since the last full. So it'll include everything in the first full plus everything that's since that in that second hour, right? What this means is if you need to restore the database, then you first restore the full backup, followed by the most recent differential, which is the second differential, right? So this is kind of how we get to, kind of a disaster recovery plan and meet our RPO and RTO, right? So for an example, and this really depends on, we talked about earlier, what your RTO and RPO is. And that depends on, are you 24/365? Are you just an 8 to 6, Monday through Friday? Depending on that will really depend on what your backup maintenance schedule and plan really means. So for example, you may every Sunday take a full, and then every day take a differential, but then every hour take a log backup, right? That every hour means is that your RPO is 60 minutes or somewhere within 60 minutes, right? You may take it every 15 minutes. You may take a log every 30 minutes. But depending on what your RTO and your RPO is, depends on what your backup schedule will look like. So typically a weekly full is okay, a daily differential is okay, and then but some people take a full every night, right? I'm not quite sure that's necessary, but again, it depends on how transaction heavy your system is and things like that, right? And what your SLA is for RPO and RTO. But this is just kind of a high level example, right? What I want to do is sort of back up and talk about differentials here. And we're going to talk about it in terms of extents and pages. So this is how differentials and logs work, right? An extent is made up of is a 64K of an extent is 64K of data made up of or comprised of 8K pages, right? Each extent has a flag basically telling SQL Server when data is changed on one of its pages, right? So I come in and I do an insert or a delete or an update or whatever, right? The extent, a page is going to be changed in an extent, and a SQL Server will say, all right, the extent will say, yep, I've been changed. A page on my extent has been changed. The flag gets turned to true, right? When a differential backup is taken, only the data for those extents where the flag has been turned on are included in the backup. Okay, that's how extents and pages and differentials work. Right? Transaction logs are different. All the transactions are just logged. But for differentials, what we're talking about is that, extents and pages. Data changes. If a page changes within an extent, the flag on the extent gets turned to true. And then when a differential happens, it just backs up those extents where the flag is turned on. Okay. So hopefully that makes sense. All right, let's talk about the log chain. We're going to talk about the log chain and log sequence numbers and really how to jack it up, right? And how that pertains to and affects your ability to do disaster recovery. So when we talk about the log chain, let's talk about log sequence numbers. right? This is, when we're talking about the log, we have to understand, well, we don't have to, I think it's important to understand log sequence numbers, okay? You can think of the transaction log as a logical string of log, as a string of log records, right? As SQL Server writes transactions to the log, they're written sequentially as a log record. Each record in the log is given and identified by a log sequence number, or LSN. As records are written to the log, the record is written to the logical end of the log, and the LSN, and that log sequence number is higher than the previous record that was written. So it's, again, a logical string. These log sequence numbers are stored in a sequence, right? So as we write to the transaction log, it's assigned an LSN, and that LSN is higher than the previous LSN. So it's just a sequence of numbers. So it creates, again, this is what we're talking about, log sequence numbers, right? So as we write, it's assigned a log identified. Each record is identified by a sequence number, and this creates basically a logical string of log records. Okay. This applies then to how we think about the log chain. The log chain then is an unbroken continuous sequence of transaction log backups, right? Each log backup is added to the chain in order. So the log chain, so let me just say it this way, an intact or unbroken log chain is what provides the ability to restore a database to a point in time. This is our disaster recovery. In order to have a valid disaster recovery plan, our log chain needs to be unbroken. So our log chain is an intact or unbroken. The key words that we need to take away from this is intact and unbroken. SQL Server is responsible for keeping the log chain intact, and it really works hard. It does its best and it works hard to make sure that it stays together. But the reality is that the log chain can be broken. It can be broken, and more, probably 99.999 times out of 10, more often than not, it's the result of something we do, a human error that breaks that log chain. When a log chain is broken, a database restore is not possible past the point where the chain is broken, right? This is how we jack up the log chain. Once that chain's broken, we can't restore past that point, okay? So we have to understand that the log chain is this unbroken continuous sequence of transaction log backups, right? And we'll see that in the demo. So each log is added to the chain in order. What we also need to understand is that this log chain must begin with a full backup. 100% must begin with a full backup, and we'll see that in the demo, okay? So when we talk about high availability, when we talk about disaster recovery, when we talk about RTO and especially, well, RPO specifically, this is where we think about our backup plan and our log chain. Our log chain is a critical part of that RPO and disaster recovery plan. Okay, this is critical to understand. So how do we jack up the log chain? And this is where it kind of gets interesting. And we talked about one of the ways. We jack up the log chain two ways. One, and we talked about this earlier, is changing the recovery mode of the database recovery mode. So remember, in order for us to take a log backup, the database recovery mode must be full or bulk logged. So when we talk about changing the recovery mode, changing this will break the chain. So remember that full or bulk log allows us to back up the chain. So if we're in full, remember that the simple recovery model doesn't back up the transaction log. So at a high level, really, going from full or bulk logged recovery model to simple model and back to full it resets the log chain. Basically, we're telling SQL Server, if we go from full to simple, we're basically telling SQL, we don't need to change or we don't need to track the log. Then if we tell it back to full, we're like, oh yeah, sorry, yes we do. So in essence, what that happens is it resets the log chain. So we go from full to simple. We're telling SQL Server, yeah, we don't care about the log. We're not, we don't care about it. But then we go back to full. We're saying, oh, yeah, hold on. Yeah, we do. And doing that resets the log chain, 100%. So when you're creating a database, one of the big points there is make sure you understand the importance of selecting the right recovery mode, right? If keeping transactions and backing up the log is important to you, then set it to full, but then don't change it. Or if you change it, understand the impact that you're going to reset the log chain, right? And it'll break the log chain. The second recovery, or the second way to break the log chain, is taking a full backup of the database, and we're going to talk about that. That's what our demo is going to be. You're like, well, that's how then do I take a full backup, right? So remember that the log chain starts with a full backup. So anytime we do kind of, we'll call it an ad hoc backup, this messes up the log chain, and this is exactly what our demo is going to show, right? So you're going, well, how does that happen? How does that jack up the log chain? I'm going to show you. And when I say jack up, it does, but it doesn't. And I'll explain that. But this is a critical piece to understand: is that anytime we do a full backup, it sort of resets the log chain. And we'll kind of walk through a scenario there. So, all right. With that, let me jump out to the demo. Jason, are there any questions so far?
No questions at this time.
Okay, cool. All right, so our log's been going. So you can see it's been taking, back. So it's been backing up our log. What I'm going to do here is look at, so the way to tell things is, actually I'm going to comment this out here. The way to look at this is we're going to look at the backup set table and the backup media family table. These are in the MSD database, right? So let's execute this query, and I'm happy to make all this code available for you to play with. So we're going to execute this, and what we see here is that there's our full backup, and then there's all the hopefully you guys can see that. Fine. There's our full backup, full recovery model, and there's all our transactions. So here's what's important to note, right? Our full backup, the first LSN is this number, 6560001, right? All the logs, starting from the first one, pertain to that first full backup, right? So this is the relationship, right? There's our first LSN, and there's our database backup LSN. So these all have the same number. That basically says these transaction logs are linked to, are chained to this full backup, right? Going to the log sequence number, here is our logical chain of, or our logical string of LSNs, right? 6560, right? There's 864, 864, 936, 936, 992, 992, right? So there you see our LSNs. These are all chained together. Boom, 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 right? This is our log sequence number. This is our chain, right? This belongs to that, that's chained to that, that's chained to that, that's chained to that, that's chained to that. So there you see all our log chain, right? Everything is intact so far. And all of these transaction logs are tied to this full backup. Okay. All right. Now let's go jack it up. And the way I'm going to jack it up is I'm going to go and do a full ad hoc. I'm going to call it ad hoc, but a full backup. So I'm going to say backup, and I'm going to just call this ad hoc backup.back. Okay. I'm going to click OK. And I'm going to click OK. I'm going to back that sucker up. So now we see, let's go back to here. There's our backup. So there's our first backup. There's all transaction logs. Now there's our ad hoc backup, right? We run this query again. Okay, there's our full, and there's our transaction log. So there's our new first LSN 2256. This log now is linked to 2256, but if you notice, the chain is the same, right? So here was the last transaction log 2112 pertaining to this. This transaction log now is chained to that one. Okay, hopefully this makes sense. However, this log now is sort of the log chain is intact, but we've sort of jacked it up because now these logs are tied to 2256, 2256 are now pertain to this last full backup. Right. What I'm going to do is I'm going to get to that in a second. So what do we mean by jacking up the log chain? Is the log chain really jacked up? Well, I'm going to say yes and no. No, in that, okay, our log chain is in order. These logs now are tied to this full, but I would say typically, a lot of times what happens is, this is part of we have a backup plan. We take our fulls on Sunday, our differentials, and they all go to a directory. Let's say, for example, we have this backup maintenance plan that does full differential logs, backs up to a directory. So if we need to recover, we know where those backups are. We can recover from those backups. The way the log chain gets jacked up is doing something I did. I'm a developer. I'm someone. I go in. I take an ad hoc backup. I take that backup and I go do something with it. Right? The DBA may not know about that backup. It doesn't know where that backup exists. Right? But that backup now exists somewhere, and it's not in. Let's say it's not in the directory where we're typically storing our. In this case, it was. I backed up to the same directory. Right, but I may just, I may go and say I'm a developer, I'm some person, I'm going to go just take an ad hoc backup, back it up to some directory. The DBA has no idea where that backup is. So if a disaster happens, if a disaster happens, I'm going to come as a DBA, come look at this and grab that last full that's part of the maintenance plan. I'm only going to be, as a DBA, I'm only going to be able to recover up until this point because I don't know about that last full backup, right? So I can only recover to here because I don't know about that. So we jack it up by taking an ad hoc and not knowing where an ad hoc full backup and not knowing where that full backup is, okay? So when we say jack it up, we jack it up by taking an ad hoc full backup and sort of not knowing where that full backup is. Hopefully that makes sense, right? So the question is, well, how do we take a full backup and not jack up the log chain? If we re-execute this, right? These all pertain to this full, but I may not know where that full backup is as a DBA. Someone went and took a full that I don't know about. Basically, if I'm a good DBA, I would go run this query and go, hey, here's a full on this date and time. Where's it at? Right? What happened to it? Right? So, but how do I take a full backup without jacking up the log chain? I may just want to grab a backup of the database that, take a quick snapshot to, restore locally on my test environment or, my local machine or whatever, and not mess it up. So the way to do that, and hopefully you guys are familiar with this, is I'm going to take another backup. So tasks backup, and the critical key thing here is this checkbox here, copy only. I'm going to do a copy only, and I'm going to call this copy only backup.back and click OK. So copy only, I'm going to click OK, done. Right, if I run this query again, what I'm going to do is I'm going to uncomment this. Right, I love this column on this table. Is copy only. So if I execute this is copy only, and execute that, notice that the first full backups, that one is not a copy only. This one is not a copy only, but the one I just took is a copy only. So if we let let another minute go by and let some more transaction logs go by, we know it has a new first LSN, but we'll show you is that it does not jack up the log chain. Right, so let's give it a minute. Right, let's give it a second to. So let me just say this while we're waiting. What is a copy-only backup? A copy-only backup is it's a full backup. It's a full SQL Server backup, but it is completely independent of the sequence of conventional SQL Server backups. So what it does is when you take a copy-only backup, it preserves the existing log archive point and does not affect the sequence of regular log backups. So it's basically give me a copy, but don't mess up the sequence numbers. Don't mess up my log chain. It basically preserves that existing log archive point. So let's execute this again. All right, we got two. Notice now these last two still pertain to this last full, right? It doesn't have a new transit. It doesn't pertain to this, right? The chain is still the log chain is still intact, right? But these transaction log backups, notice that these numbers pertain to this one, this last full, not this copy only that we took. Okay, so that's how we preserve the sequence of regular backups. This is how we don't jack up the log. And when I say jack up, that's kind of harsh. We take a full backup. If we don't do copy only, logs go, but we got to make sure that we know where that full backup is. So the safest thing to do is just take a copy only. If you need a backup, just grab the last full. Don't take another copy. Just, ask your DBA where the last full backup is that you can grab. But if you need one, make sure you do copy only. This log chain is critical and essential for your disaster recovery plan and your RPO. Right? So we're taking a backup, a log backup every minute, but this says I've got an intact log chain. So if I didn't do this, if I hadn't done this, I have an intact log chain that I can recover. So let me give you an example. Let's say I'm doing full and some differential and logs. So I would restore my full. I would then restore the most recent differential, and then any logs since that most recent differential. Okay. Don't jack up your log chain by doing a full without doing copy only, right? Either grab the last full or do a copy only. Because here, hopefully this makes sense. When I did a full without copy only, it didn't reset the log chain, but basically said, all right, all new logs now pertain to me, not the previous full backup. Right. So if I don't know as a DBA, don't know where that full backup is, I can only restore up to this point right here. That's it. Right. So I've lost, if these logs were taken every hour, I just lost 7-8 hours worth of data because I don't know where this full is. Okay. So hopefully that makes sense. That's how you jack up your log chain by either changing the database recovery mode or taking an ad hoc full backup without doing a copy only. Okay. Let's jump into, I think we're done here. Yep. So, all right, so hopefully that makes sense. Let's do a quick recap, right? We talked about high availability disaster recovery, the importance of understanding the differences. We talked about RTO, recovery time objective, and recovery point objective, how much time it takes to recover from a disaster and the acceptable amount of data loss, your RPO, recovery point objective, acceptable data loss when you're recovering from a disaster. We then talked about the different types of backups, full, differential, and logs, and extents, and things like that. So hopefully that all made sense. And then we ended up with talking about our, jacking up your log chain, how to jack that up, right? Hopefully this makes sense. Kind of a little bit of high level, but we see this frequently, and so we want to make sure that this is out there and people can come understand, you know, how not to jack up your log chain. So here's my contact information. If you want any of these scripts, including the .NET app and any of these SQL scripts, please email me. I'm happy to send them to you. This recording will be posted on the on our SQL Solutions Group YouTube page, so you can go view it anytime. But if you have any questions, please feel free to reach out. What we do want to know is, you know, if there's something that you have a question about that you know, we're happy to do a webinar on anything. Like we're currently doing some SQL Server migration webinars. If you have performance, if you have a idea for a future webinar, let us know. Email me, email Jason, or put it here in the chat, and we would love to do a video on that. All right, well, hopefully that was helpful. That was 50 minutes of backups and jacking up your log chain. Any questions?
No questions as of yet, Scott. I'm going to post a link to next month's webinar in the chat. There it is. We are focusing, excuse me, on migrating DBA tools, and Randy Knight, our principal consultant and founder, will be leading that one.
Yep. Good. Well, hopefully this was helpful to all of you that were watching. I enjoyed doing this, and hopefully this was helpful and beneficial. We'd love your feedback, whether you thought it was helpful or not, or any feedback for that matter, what you thought. But thank you very much. We really appreciate your time.
Thanks, everybody.
Thanks, everybody. Have a good day.